Hello everyone, I'm Mukesh Kanchan and this is my final project, Image to Sentence Generation. Uh, Image to sentence generation or image captioning is a popular deep learning topic. It has several uses. Most prominent uses is the ability to search image by indexing them on their description or caption. Other use what I found is especially for visually impaired people, there could be you know conversion of image to text or audio. Although there are some other technology also for that, but this could be one of the use for them as well. This involves computer vision and natural language processing. In terms of and neural network models used for this technology are CNN and RNNs. So let's start building better sentences. Let's move forward. To start with, let me talk about the data sets I found to be used for this project. There are two data sets very popular. One is Flickr 8K. This is a small data set with more than 8,000 images coming from old Flickr website, which is split in three parts. And then you have a separate file where you have the tokens. Tokens are nothing but 5 captions for each images, as you can see at the bottom. Second data set is MS Coco. This is quite big database, more than 82,000 images. It is provided by cocodataset.org. It has all the images stored in train 2014. I mean, that shows like it was developed in 2014. And then all the annotations or captions or descriptions are stored in a JSON file in a folder. The challenge with both the data set is like if you want to do a subset of images, we have to modify these files, annotation files manually, which can create problem. For that purpose, I have not taken like a subset. Means you can take subset programmatically in the code or select a less number of images, but you cannot do at the file level. That's the reason I have not submitted that along with my code, and we need to download to make it work. All right, moving forward. As I said, like this entire solution is based on CNN and RNN. For CNN, I'm using a popular Inception v3 for image encoding. All the details are available on the internet, like it is developed by a group of team mentioned above. So what we did is like we passed our images through this network and got the encoded output at last but one layer and stored it to use in my models. So first model architecture for approach one was like this, where all the encoding were coming here. Then I had a dropout layer, a dense layer. Similarly, on the other side, I use Grove vectors, which has pre-trained weights on this embedding layer. And our captions, whatever captions on the training database, I created a word to index direct dictionary, which came here. So we had input layer which had word to index of a training captions dictionary. Then we had the weights from glow vectors, then dropout, LSTM, long short-term memory layer. And then we had decoder layer. First layer was just adding those two. And then dense layer, which has a ReLU activation as a decoder 2. Then finally a dense layer, which had the softmax activation. So this was the model for approach 1. For approach 2, it was a little bit different. Like we had a same CNN encoder, but this time we had just single dense layer and was directly passed to the RNN decoder. For RNN, I use GRU. And before GRU, I had an embedding layer where I passed all the training caption, which are tokenized. And then I had a two dense layer, and I used but now attention here. So this is architecture of approach 2. Now, and as I said, like this architecture is a popular architecture as published as a show attendant tail paper. And I just use that architecture for my project. So I run the model and try to check the blue score of the test images on based on the what is the production caption and what was the actual caption. As you can see, it doesn't give much sense, but uh, highest blue score came in approach 2, that is nearly 0.5. So let's see the output, how it comes to our observation. So these are the images which is not part of our database provided, but these are two images I just select from outside and try to see what kind of output I'm getting. So approach 1, you can see totally off the mark, right? It says man in black shirt is riding bicycle on a city street, which is not at all true. Other than looks like a street, but it's a road actually. And second, dog is running through the grass. There is no dog, no grass. Although cat is quite big and looks like a dog. So approach 1 was not on the mark. But if you look at the approach 2 output, a car driving down the road during the days, perfect. And a brown, beige, white kitten sitting in front of a roof. All three color came really correct. Brown, beige, and white pieces are there. So a roof is there. So approach 2 is much better performance in terms of predicting the captions. So in the larger video, I will walk through the code, but this is the overview video I wanted to share with you. Thanks for your time. Hi, let me give you the code walkthrough of both the approaches for image to sentence generation. The first approach, we started with importing all the relevant libraries, then loading the Flickr 8K data, right? So I got this from GitHub URL and unzipped them in data folder inside my working directory. And also I got downloaded Globe 6B data from this Kaggle website and put in this particular folder, right? So I defined all the path for my file, like where my training image is there, test image is there, where tokens are there, where is Globe, vectors are there. So we kind of loaded it. Now we want to create a dictionary of all the descriptions or captions. So for that, like I went through all the lines and kind of look for the wherever the special characters are, right? And we also just like to have a look. I printed something just to look like 866 record I printed, like how many captions are there, you can see it, right? Similarly, then after that I did a basic cleanup. Means I removed all the punctuation mark and everything, and then I joined it, and I'm just printing image and corresponding captions of the same. You can see that. So altogether we have 8,000 images around. So it's a 40,000 image description we are talking about, right? So this is size, exact size, you can see that. Now we are recreating the file structure with image name as key and corresponding, clean description what we created. That's what we are doing here. Then we are loading the training image file and from this particular whatever training image names are there, and then finally creating a training and testing image in the memory, right? These two variables we are creating here, which has all the file names. Then loading the description in the dictionary. I'm appending this start and end level also token also to distinguish it. So that's there, right? So now we are kind of prepared, and one thing we are more doing is if some words are repeating more than 10 times, then we are kind of limiting it. And so anything less than 10 we are not taking it. So okay, so which are at least 10 times which are appearing, we are taking that in vocabulary, right? So our size is this, so it is reduced from large number to this, which is kind of maintainable. Then I'm creating index to word to index kind of, references, which in the dictionary, so that I can, refer to word with the index, and and later on I can convert it from index to the word. And also I'm using, as I said, like a Globe word embedding. So I'm loading it from the file what I downloaded, and kind of creating an embedding vector, which will I pass as a weight to the model later on. So now creating the model, the first CNN part is taking in the inception v3, then taking the last but one layer and passing all the images, generating the encoding. Once encoding is generated, then I'm creating my own model with all these layers, which I could explain in the PowerPoint. Then in that layer, like basically in that model, I will pass what I got from the inception v3. So I'm also in the second part, I'm sending the embedding matrix, which is calculated from Globe, word vectors. And then I'm ready to, create batch and run it. So this created where I can create a sizable batch, and I'm running it for 30 epochs. When it's done, then I have written a function to evaluate the model, predict sentence. So that's what I'm doing here. I'm passing the image and getting a description along with the blue score. I'm using Corpus Blue. So if you see, like original description is this, predictor is this. I only talk about all this thing in my presentation. And the performance is really not so great. As you can see, this says a dog rather than a cat. Now let's go to the approach 2. In the approach 2, if you can see, like again, the same thing, starting with importing all the libraries. This time I'm using MS Coco, which I downloaded from this website. Again, I'm zipping everything under the .NET data folder and defining the path. This is path for images. This is path for the captions, right? Again, and now I'm doing loading all the this thing and putting the start or end tokens there. Total number of images 82,000. And creating image, these arrays where I'm putting description and image. I'm just putting one example how to look, how does it look. Now we will pre-process image through inception v3 model, as I said, like so that's what I'm doing, and created that function for that. Once this is done, I process all these 5174 images, and I have stored that as in my file system, right? Now we'll tokenize all the caption. I will take top 5,000 words and other will mark as unknown. This is just to save some performance, otherwise there will be a lot of small words with just one or two occurrence, right? So now I will go through. Now we will create test and train data at 20% breakup. This is what we have done. Then now I will configure my batch size and everything. To run the model, I created the model as I explained there. I have used Bandau attention. This entire structure is taken from this particular, paper written and actually created for a SOTEL attention, white paper. So it is totally taken from there, and I have described this in my presentation. So I'm not going there. So once this is done, I have to define some checkpoints so that in intermediate situation can be saved, and I can restart from there if something happens. Now I'm training the model. All the features stored in NumPy and NPI file is passed to the encoder. Then from encoder, whatever is coming is passed to decoder, and that way. So I have written train step function which will go through this and calculate the gradient descent using the optimizer we defined, right? We are running for 20 epochs, and it really took some time. You can go see like its entire output going epoch by epoch. For 20 epoch, I'm printing after every 50 batch size just to make sure something is happening. So after 20 epoch is done, I am ready to test my model. Again, we can predict caption function, where I will pass the validation image, which will give me the predicted kind of caption. So this is what I have done. I passed this image, and I got so actual caption or real caption was this, and the prediction caption was this, which is still good. A blue score is also okay. I mean, so one of the case I got really high 0.5 kind of. So this was good. And if you look at the image which I took from outside and tried that, performance is much better. You see that car driving down the road. It's really good. So that's all on the code walkthrough. Thank you. Thank you for your time.